Every project comes to the most critical test. This is where you know whether you are on the right track or you've just wasted a bunch of time. This time is no different. Testing the motor tied to the pump is a critical part of this build. I've had some concerns because the pump is rated for 10 horsepower, while the motor is rated for 7 horsepower. Fortunately, Chinese horsepower seems to be weaker than European horsepower. Before I started this project, I had two motors to choose from. One is rated for 7 horsepower and the other one is rated for 10 horsepower. While the pump is rated for 10 horsepower, the second motor should be a perfect match, right? Of course, but then comes the economic aspect of this project. I found a 7 horsepower VFD locally for a really good price. Keeping in mind the Chinese 10 horsepower most likely is not even close to what the seller specifies, I've decided to go the cheap way. While the pump was on its way, I've done some tests of the motor and the VFD just to check everything works as it should. After learning how to use the Schneider electric VFD and testing the motor, it was the time to wait for the pump to arrive. In the meantime, I made the project of the entire machine in SolidWorks, keeping in mind to make some breathing space for the pump. That's why the frame is a little bigger than it has to be. The shipment of the pump took long enough so I could build the entire frame, as you could see in the previous video. After confirming everything fits nicely inside the frame, it was the time to assemble the most crucial part, which is the motor and the pump, and do some real tests. This is the part where everything could turn into a bunch of wasted material or several days of rebuilding the frame to fit the bigger motor. Not mentioning sourcing the bigger VFD, as the one I've ordered will not be able to drive the 10 horsepower motor. The test I've performed is very simple yet very important. Will the motor be able to power the pump under the full load? To answer that question, I did the very basic configuration to operate the motor. VFD is connected to 3-phase power from my junction box. The motor is connected to the output of the VFD with basic configuration for operation. This means the potentiometer to set the motor speed and emergency switch for starting the motor. The test I've performed answered my biggest doubt. The motor was able to power the pump with ease, as I've assumed the pump is not really rated for 10 horsepower, so the 7 horsepower motor is a perfect match for this. While doing the test, I've checked several things: the motor current, its temperature, the speed of filling my pressure system, and the temperature of the air on the compressor output. If the motor would not be powerful enough, it would stall at the bigger load. So with the pressure system close to being full, with the 100 liters worth of tanks and 7 bars of pressure, the motor was nowhere near stalling, which is the greatest news. Motor current reached 10 amps at its peak, which is pretty much its nominal value. The motor stayed cool during the entire operation. The pressure system was topped up within a minute. I was really surprised and happy to see the motor is pretty much a perfect match for this pump. This answered many concerns I had before doing the tests. Even though I did calculations whether the motor would have enough power, which by the way told me it will not, taking the Chinese manufacturer factor, I've decided to take the risk, which in the end was a good decision both for economic and mechanical aspects of this project. One concern unfortunately still stays valid: the temperature of the air on the output of the pump. It's not a surprise, squeezing air generates a lot of heat. With my current air system made of PEX tubes, the temperature becomes a serious risk. I'll need to find a solution for this issue. I'm thinking of making my own high pressure active radiator on the pumped output or replacing the first 3 to 5 meters of the air line from PEX to steel for better durability and cooling. If you have any good solutions or ideas on how to address this issue, feel free to leave a comment. The next step for this project is the control cabinet. It's the most tedious and time-consuming part. This will also answer some more questions within this project. Is the pump controller I made good? Are the safety features I've planned robust and reliable? While these questions still needs to be answered, that's it for this video. As always, thank you for watching and I will see you in the next one.